Awesome. Welcome, everyone. Welcome to today is September 15th. A happy first day of Hispanic Heritage Month. Hispanic Heritage Month goes from September 15th to October 15th just to celebrate the heritage of the Hispanic people. And so today we are going to get started with our study sheet. So if you can go to your study sheet right now, that would be great. We're going to go over it. Obviously, we won't have time to go all of it because only 50 minutes we have, but we will be going over some major points, okay? So we're going to go over some major again. Awesome. So as we go down here, the vocabulary, I feel like we don't need to go over. I already told my synchronous students. I feel like you guys can do that pretty easily. The definitions are not that hard. But if you ever feel like there's a word you don't know, just let me know and I can help you guys with it, okay? But we'll skip those vocabulary words. They're pretty self-explanatory. Let's start with the questions. So it says, the first question says, write down the 2 ways of writing the units for energy. And we have one of our scholars right here, Sarai. He was able to find one of the first ones. The first one way of writing the units for energy is joules. Remember, it's pronounced like jewel, like jewelry, but it's spelled like this, joules. So I'm going to put this a little bit bigger so we can see it. And the second one is a little bit tricky. I didn't mention it too much into it, but I did mention it in our 1.2 handout. And basically that one is, because remember, what did we learn about? There's 3 ways, the 3 main units, right? Our 3 main units are kilograms, mass, and second when it comes to physics. So if you combine them together, you can actually make joule, which is kilogram times meter per second squared, meters squared per second squared. Now that looks a little bit weird. So let me see if I can make this into the actual equation. Just so it can look better. So equation. So kilogram times meter per second over second squared. There you go. That looks much better. So this is the one right here. Kilogram times meter squared per second squared. Okay. That is the other way of writing the unit for energy. The most common one is joules, but there's also this way of writing it. And the reason I want you guys to know that is because it has the 3 main units we'll be using for physics: kilogram, meter, and second. Okay. I'll give my synchronous students a little bit of time to write those down. Okay. Awesome. Now, let's do on the second one. What is the formula for writing total energy? What do we know about total energy? Remember, total energy is what is it specifically, right? So we know total energy is the sum of what though? No, it is the sum of, awesome, thank you. Sarai was able to message me that. The sum of kinetic energy, Ke, plus potential energy, Pe. Now we'll make this a little bit prettier just so we know, so we can identify them correctly. So the sum of kinetic energy and the sum of potential energy. Remember, it's the addition. You add them together, right? Boom. So if we do some examples, basically, if you fill in the blank, if 35 joules is the total energy and 30 joules is the kinetic energy, then what plus 30 joules equals 35? If we know our math, it will be 5 joules. So 5 joules plus 30 joules equals what? 35 joules, right? Remember, it's the sum. Total energy is the sum. So basically, you're just trying to fill in the blanks, right? So the next one, negative 250 joules plus something equals 100 joules. This is a little bit a tougher math, but if you know your math correctly, you will know that 350 joules plus negative 250 joules equals 100 joules. Okay. And the last one is 45 plus 45 equals what? 90 joules of total energy. Remember, all we're doing is just adding them together to create, to to find out the total energy being used. Okay, that's it. That's all we're doing. Okay, some pretty simple math here. Okay, nothing too crazy. Okay, so this is the first section that we're doing. Now let's move on to the next part. I'll actually, if my synchronous students need to copy this down, I'm actually gonna pause this real quick. Back. Okay, the next one is, where does energy transfer to? Well, thank you, Daniela. She was able to message me. It transfers from hot to cold. So it transfers from hot to cold. Not from cold to hot, but hot to cold. There you go. That way you can see kind of a little visual like that. The reason is hot energy moves faster. So anything that's hot moves so quickly, has so much energy. If it sees something cold, whether it's molecules, objects, rain, water, whatever it is, the hot will travel to the cold so it can transfer that energy. So always hot to cold, okay? Always know that. Ooh. Look at some examples. This is writing some examples of systems and surroundings. We know systems is our main focus, and we know surroundings is everything else, right? So I made an example right here, an arrow flying across the sky. Well, we have an arrow is our system. It's our main focus. What is around it? The sky and the air. The universe is just both of them put together. So arrow, sky, and air. And we know it's an open system because both matter and energy are traveling in and out. So some other examples that we got was, what are some examples? Some examples that we got was, oh, I feel, we got some, oh, I'm having trouble. A fridge. Oh, there you go. Thank you, Daniel. I was having trouble finding it. So yes, a fridge is our circumstance, right? So we focus on the system. We know the system is just the fridge itself, correct? Yes. And if we actually go into specifics, the surrounding is everything around it, right? So the food around it, the electricity around it, electricity. Maybe even the stove or the microwave around it. We know those are all our surroundings, right? Because the fridge is our main focus. And we know that the universe is the fridge, the electricity, and everything put together. I can't spell today, but it's okay. You guys get the drift. Thank you, Daniela, for chatting with me on that one. I was having trouble finding it, so thank you so much. And she put that the example is a closed system because with food, matter can't leave, but energy can come in and out. So even though you can't leave, like if the fridge is closed, you can't take out things out of it, like matter, like the food or the ice, but energy still travels in and out, like electricity and air. So good job on that one. I believe there may not have been another example, so I'll just put one more example. Actually, there was another in there example. You put the tree, right? Tree, sunlight, and soil, rocks. Okay. So a circumstance could be a tree. Ooh, tree on a hill. If we focus on the tree, which is our system, then everything around it, the hill, the sun, the air, maybe the grass, that's our surroundings. And the universe is everything put together. Hill, sun, air, grass. And there's an open system because you can transfer matter and energy in and out. Thank you so much, Daniela, for that one. Awesome. Oh, I hope I started sharing thing again. Yeah, right there. Okay, sweet. And for isolate, we actually won't focus on isolated. Like I said, it's not that common. So even though I put that, we don't need to worry on that one. Don't worry. It's not going to be tested on that one. So don't worry about that. Let's move on to the next one. Fill in the table below by using the figure above. So let me see if I can actually make this a little bit bigger. I cannot. That's unfortunate, but it's okay. So with this one, actually, I'm so sorry. Let me pause this real quick. I feel like I was going too fast. Let me just pause my recording real quick in the future. Awesome. Let's move on down here. Now we have a pendulum, a swing, right? I've used this on our demos, on our lessons. I have point A, point B, and point C, right? So let's fill in the table to figure out the characteristics of this swing. So where will maximum kinetic energy be located? We know the maximum kinetic energy is located at point B. I did the first one for you. At the lowest point is when it's traveling the fastest, right? So you have to fill in the table. So according to what Layla and Emily filled out, they put that there is, on the next one, it says maximum potential energy. There is maximum potential energy at point C. Good job. So the max PE, I'm gonna be a little bit, no, I'm not gonna be lazy. Let's do the whole thing. The max potential energy is located at point C, but not just point C and point A, because they're both at the highest point. So that means at the highest point, the object is not moving. The ball is not moving. So if it's not moving, that means it has max potential energy. So it's 2 points, point A and point C, okay? Awesome. Now, where is this zero kinetic energy? So it's the opposite, right? Where there is max of one form of energy, there is zero on the other one, right? So if there's max potential energy at point A and C, that means there is zero kinetic energy at point A and point C, which seems like some of my scholars. Okay, yes, so there is. So the zero kinetic energy is located at point A and C, okay? Because it's the opposite of where the max is. So if there's max on one form, it's gonna be zero on that exact same location. So if we go down right here to where it says potential energy, if we know that the max kinetic energy is at point B, that means there's gonna be zero potential energy at what? At point B. So the zero potential energy is located at point B, okay? At point B. Oh, I don't know why I put that timer out there. Now, let me see what my scholars put on the next one. The ball is at rest. When is the ball at rest? Let's see. They are the ones that have the right movement. Yes, thank you. So the ball is at rest. It's not moving where there is the max potential energy. So at the highest points, the ball is resting. And I'm going to put hashtag not moving. Not moving at point A and C. Remember, where there's max potential energy, that means nothing is moving. So where there's max potential energy, that's where the ball is resting. So where there is max potential energy, okay? I'm gonna put this a different color just so I can emphasize more of this. Put that in red. Now, where is the ball traveling the fastest? Well, we know that where there's kinetic energy, there's movement, right? But where is the max kinetic energy is where the ball is traveling the fastest or the most. So the ball is traveling the fastest at point B, which is where there is max kinetic energy. Thank you, Layla and Emily, for that. Make sure I give you all core value points. There you go. Now I'm going to give my scholars, my sync students, a time to fill that out. Awesome. So the last part we have is the CER statement question, right? Remember, on your test, there's going to be one big chunk where it's going to be a short answer response, and you have to do it in CER statement. In case you forgot what that means, which I hope you didn't, but in case you forgot, it's a claim, evidence, and reasoning statement, right? So it's how you answer questions, how you properly answer questions. Okay? So I'm gonna actually make this a different color. Let's make this, let's make it like a little, just like blue. It's how you properly answer questions, okay? Now, you guys have been working on this. It's actually, if you click on this link, there's a graphic organizer that you have been using to help you answer these questions, right? So I have a graphic organizer right here for you. So you already have the question. All you gotta do is just be able to answer it, right? So the question on the test is gonna be, if you wanted the apple to hit Mr. Castillo's face, what would you need to do in order to make sure that it happened? Now, oh my gosh, I need to burp, sorry. Now, this question is based off the lab demo, the apple on a stick lab demo on the Edpuzzle. You know, as I put the apple against my nose and I let it go, when it came back towards my face, it did not hit my face, right? And you're able to tell me why it didn't hit my face. But what would you need to do if you actually wanted the apple to hit my face? What would you need to do for the apple to actually hit my face? So that's what you have to answer that question. So give me a claim. What's your answer? Evidence. How do you know that it will work? And then reasoning. Why did you choose that answer? Okay. So if you want the apple to hit Mr. Castillo's face, what would you need to do in order to make sure that it happened? I'll put some pointers right here to help you out. I'm going to put notes. Note. Remember about energy and how it transfers. It's all about energy and how it transfers. So just if you keep that in mind, you should be able to answer the question accordingly. Okay. Boom. So that's basically the extent of that question. Like I said, this is going to be the biggest part of your test. So make sure you are able to make a CR statement accordingly and make sure you're able to make it in a way that's very understandable. Okay. Okay. For my A-Sync students watching this, you guys are officially done with the study sheet. So this is for your own understanding, for you to prepare you for the test. So make sure you fill it out completely. Make sure you also fill out the vocabulary words because I'm going to be testing you on those vocabulary terms. And if you have any questions, like I said, you can always contact me through any of the platforms that we have. Make sure that if you want to ask a question and you don't know the answer to the question, I would definitely encourage you to go to Piazza and ask a question there. Remember, if you go to Piazza, if you go to where it says questions, confusions for understanding, it's already pinned. You can actually ask a question in this section and I can answer them accordingly. Or you can actually go to the office hours Q&A folder and you can actually ask a question there as well. So if you have a question, definitely use those platforms and I'll be able to answer them accordingly. Okay. And that's pretty much it for that. I hope you guys have a great rest of your day.